Exploring the synergy between AWS and DevOps. In the rapidly evolving landscape of cloud computing and software development, the combination of Amazon Web Services, AWS, and DevOps has become a powerful strategy for organizations looking to streamline their operations, enhance collaboration, and accelerate the delivery of high-quality software products. AWS provides a comprehensive set of cloud services, while DevOps promotes a culture of collaboration and automation. In this video, we will delve into the world of AWS and DevOps, exploring their features, benefits, and practical examples of their synergy. Synergy between AWS and DevOps. Combining AWS and DevOps offers numerous benefits that empower organizations to deliver software faster and with greater efficiency. Let's dive deeper into the synergy between AWS and DevOps, exploring various aspects of how these two powerful concepts work together to enhance software development and operations. Scalable infrastructure and automated scaling. AWS provides a vast array of services for building scalable and flexible infrastructure. DevOps complements this by implementing automated scaling strategies. For instance, a DevOps team can leverage AWS autoscaling to dynamically adjust the number of instances in an application fleet based on traffic and performance metrics. This ensures that the application can handle varying workloads without manual intervention. As demand increases, autoscaling provisions new instances, and when demand decreases, it automatically scales down resources, optimizing costs. Elasticity and cost optimization. AWS's elastic nature enables resources to be provisioned and deprovisioned as needed. DevOps practices ensure that this elasticity is leveraged effectively to optimize costs. By integrating AWS budgets and AWS Cost Explorer, DevOps teams can monitor and control spending, set budgets, and receive alerts if costs exceed predefined thresholds. Automation in DevOps ensures that resources are allocated appropriately and are aligned with actual usage patterns, avoiding over-provisioning and wastage. Infrastructure as Code, IAC. IAC is a fundamental DevOps principle that treats infrastructure provisioning and management as code. AWS CloudFormation and tools like Terraform enable DevOps teams to define infrastructure components, configurations, and dependencies in code. This approach ensures consistency, repeatability, and version control in provisioning AWS resources. Changes to infrastructure can be tracked, reviewed, and applied using a code-based approach, minimizing errors and ensuring infrastructure is aligned with development and testing environments. CI/CD pipelines and automated deployments. AWS offers a suite of services for building robust CI/CD pipelines, while DevOps practices ensure that deployments are automated, reliable, and frequent. Teams can use AWS Code Pipeline to create end-to-end CI/CD workflows that automate code builds, testing, and deployments. Integration with AWS Code Deploy enables smooth, automated application deployments across multiple environments. DevOps teams can establish fully automated pipelines that facilitate rapid and consistent software releases, reducing manual interventions and lowering the risk of errors. Monitoring, observability, and incident response. AWS provides monitoring and observability tools, and DevOps practices emphasize real-time monitoring, alerting, and incident response. AWS CloudWatch offers a comprehensive set of monitoring and logging capabilities for AWS resources, and DevOps teams can enhance this by integrating with third-party observability tools like New Relic or Datadog. By setting up automated alarms and dashboards, DevOps teams can gain insights into application performance, infrastructure health, and potential issues. When anomalies are detected, automated incident response workflows can trigger actions such as scaling resources or alerting the appropriate teams for investigation and resolution. Serverless architectures and microservices. DevOps can leverage AWS Lambda and other serverless services to build microservices architectures that scale automatically and minimize operational overhead. AWS Lambda enables developers to focus on writing code without managing the underlying infrastructure. DevOps practices ensure the proper deployment, scaling, and monitoring of Lambda functions within a larger application ecosystem. This approach supports rapid development, efficient resource utilization, and seamless integration of microservices. Data pipelines and automation. AWS offers services like AWS Glue, Amazon Kinesis, and AWS Step Functions for building data pipelines and workflows. DevOps practices help automate data processing, ETL, extract, transform, load, operations, and analytics. By integrating these services with CI/CD pipelines, DevOps teams can ensure that data pipelines are versioned, tested, and deployed consistently. Automation in data pipelines streamlines the movement and transformation of data, enabling organizations to derive valuable insights from their data assets. The synergy between AWS and DevOps brings a wide range of benefits to organizations, from improved scalability and cost optimization to automated infrastructure provisioning and reliable software deployments. By harnessing the capabilities of AWS services and integrating DevOps practices, teams can create a culture of collaboration, continuous improvement, and innovation that drives the successful development and operation of modern applications in a rapidly changing technology landscape. Practical examples. Let's explore practical examples that showcase how the synergy between AWS and DevOps can be applied in real-world scenarios to achieve efficient software development, deployment, and operations. Automated deployment with AWS Elastic Beanstalk. AWS Elastic Beanstalk is a platform as a service (PaaS) offering that simplifies application deployment and management. DevOps teams can leverage Elastic Beanstalk along with AWS code pipeline for automated deployments. Example: an e-commerce application wants to streamline its deployment process. The DevOps team sets up a CI/CD pipeline using AWS code pipeline. Whenever developers push code changes to a GitHub repository, code pipeline triggers the pipeline, which includes stages for building, testing, and deploying the application to Elastic Beanstalk. This automated pipeline ensures that code changes are tested and deployed consistently, reducing manual intervention and speeding up releases. Infrastructure as Code (IaaC) with AWS CloudFormation. AWS CloudFormation allows DevOps teams to define and provision infrastructure resources using code templates. This approach ensures consistent and repeatable infrastructure deployment. Example: a media streaming platform needs to create a new environment for content processing. The DevOps team defines the infrastructure requirements using CloudFormation templates, specifying resources like Amazon S3 buckets, AWS Lambda functions, and Amazon EC2 instances. As the application evolves, changes to the infrastructure can be easily managed through version-controlled CloudFormation templates, enabling seamless updates and rollbacks. Serverless microservices with AWS Lambda and API Gateway. Serverless architecture simplifies development and operations by abstracting away server management. AWS Lambda and API Gateway enable the creation of serverless microservices. Example: a ride-sharing app aims to enhance its location-based services. DevOps teams design and deploy microservices using AWS Lambda and API Gateway. These microservices handle geolocation requests, user authentication, and trip booking. The DevOps team sets up monitoring using AWS CloudWatch to track function invocations and latency. As the app gains popularity, the serverless architecture automatically scales to handle increased user traffic. Data processing with AWS Glue and Amazon Redshift. DevOps practices can be applied to automate data processing pipelines, enabling efficient data analysis and insights. Example: a healthcare analytics company processes large volumes of patient data for research. DevOps teams design a data pipeline using AWS Glue to extract, transform, and load (ETL) data into Amazon Redshift. This pipeline is orchestrated using AWS step functions, automating the entire process. Regular updates to the data pipeline are automated through CI/CD pipelines, ensuring that data processing remains up to date and accurate. Monitoring and incident response with AWS CloudWatch. AWS CloudWatch provides monitoring and alerting capabilities that can be enhanced through DevOps practices for proactive incident response. Example: an online banking platform wants to ensure uninterrupted service availability. DevOps teams set up CloudWatch alarms to monitor key performance metrics like CPU utilization and latency. When a threshold is breached, CloudWatch triggers automated responses, such as scaling resources or sending notifications to on-call engineers. The DevOps team continuously refines the alarm thresholds based on historical data and user behavior, optimizing the application's performance and reliability. Continuous integration and deployment with AWS Code Pipeline and Code Deploy. AWS Code Pipeline and AWS Code Deploy facilitate streamlined continuous integration and deployment workflows. Example: a software company develops a mobile app with frequent updates. DevOps teams configure a CI/CD pipeline using Code Pipeline, integrating GitHub repositories for version control. Each code change triggers automated build and test processes, followed by deployment to Amazon EC2 instances using Code Deploy. The entire process is orchestrated and monitored, ensuring consistent and reliable app updates without manual intervention. By implementing these practical examples and leveraging the synergy between AWS and DevOps, organizations can achieve faster development cycles, efficient resource management, reliable deployments, and improved overall software quality. This integration empowers teams to focus on innovation and customer value while maintaining a culture of collaboration and automation. In conclusion, the integration of Amazon Web Services, AWS, and DevOps practices offers organizations a potent combination for modern software development and IT operations. The features and benefits of AWS align seamlessly with the principles of DevOps, fostering collaboration, automation, and continuous improvement. By adopting these technologies and practices, organizations can accelerate their software delivery, enhance scalability, improve efficiency, and ultimately provide better value to their customers. As cloud computing and software development continue to evolve, the synergy between AWS and DevOps will undoubtedly play a pivotal role in shaping the future of technology-driven businesses. Please subscribe to our posts at www.a2zofsoftwareengineering.blog. Follow our podcasts and videos available on YouTube, Spotify, and other popular platforms. Have a great reading, viewing, and listening experience.